So in this video, we're going to take a look at the volume of cones and spheres. So a cone is a circular base that, unlike a cylinder, it tapers off to a point at one end. It's kind of like a circular base pyramid. And actually the formula for a pyramid is very similar to that of a cone. And we have a given radius, and then for that cone we'll be given the inside height there. There's actually based on a right triangle inside there. So there's our height of our cone. So radius and height are the two pieces. The volume of a cone works out to be 1/3 the volume of a cylinder. So 1/3 pi r squared h. So very similar to our cylinder, other than we have a 1/3. So 1/3 times pi times radius squared times the height. And again, like I said, this is very similar to a pyramid. It's the area of the base, the pi r squared, times the height times a third. You could take the area of the base of a square base pyramid and multiply that by its height. You could do that with the pyramids in Egypt, and you could get the volume of stone approximately that is in there, minus any of the weird shafts and things that are in there. The volume of a sphere is a little different. Still works in the same idea of using that third portion. Now a sphere, when I draw them, tend to just try and put a dashed line around like this. In the textbook type questions and that, they'll try and make a gradient and make it look three-dimensional by using some color and that. I'm not that good of an artist, so I'm just going to draw a dashed line like that to show this, and then we will have a radius value inside here. So the radius of the circle or of the sphere is all we need to calculate the volume. So the volume equals 4/3, in this case, pi r cubed. So the volume is equal to 4/3 times pi times the radius cubed. And so if you want to recall from the last video, we had just mentioned that, and I didn't finish this, 1 liter equals 1,000 centimeters cubed, or 1 meter squared equals 1,000 liters. So we have those two conversions for capacity. Remember that volume is the measure of the space something takes up. The capacity is how much will fit inside. So we want to calculate the volume and then the capacity of each of these figures here. So we're going to start with our cone. So for part A here, the volume of that cone is equal to 1/3 pi r squared h. And so we have 1/3 times pi times the radius. Well, this whole thing across is 3.5, and that would be our diameter. So our radius is half of that. Half of 3.5 is 1.75. We just divide that by 2. And then our height is 4.2 meters. So we get all that together, and then in our calculator you could type in 1 divided by 3 times pi times 1.75 times 4.2 if you have a pi button on your calculator. If you don't have a pi button on your calculator, it's okay. You can use 3.14 And you should approximately get the number 13. 0.5. So 13.5, and that would be meters cubed. So you get approximately 13.5 meters cubed for your volume. Round it to 1 decimal place. And if you then want to calculate the capacity of that, B capacity. So again, we got meters cubed here, and so we have 1,000 liters in a meter cubed. So 13.5 times 1,000 is going to give us 13500 liters. 13,500 liters in that cone. And then our sphere here, we have a radius of 9.5. So we need to plug all that into the volume formula first. So the volume equals 4 divided by 3 times pi times r cubed. So we fill all that in. 4, and again, I can even write it like this. 4 divided by 3 times 3.14 times 9.5 to the power of 3. And so I work all that out, multiply those together, put my 9.5 to the power of 3 first, and I end up with an answer approximately 36,000 meters cubed. Or sorry, 3,600 meters cubed. And so there's our volume. And then to calculate our capacity, we would multiply that 3,600 by 1,000. And our capacity then would be 3,600,000. So just add 3 zeros on the end. 3,600,000 liters. To put that into perspective, that would be a 3,600,000 1-liter cartons of milk. It's a lot of milk. All right, for some questions out of the assignment sheet included, we're going to be looking at numbers 1, AB, 2, AB, 4, 6, and 7. So 1AB, 2AB, 4, 6, and 7. Those would be some good problems to check out. Maybe one more. Let's do one more. Number 9. Let's try number 9 too. That'd be good. So 1AB, 2AB, 4, 6, 7, and 9 for some questions to do out of the handout.